Hello and welcome back to Sustainable Picture. If it is your first time here, my name is Leticia and I'm glad to meet you. And if you've been here before, I'm happy to see you again. So in today's video we keep going with this unit about landform modeling, and for this video and the next video we will learn some specific types of landform modeling associated to some agents. Mainly it's gonna be water, but different types of water, but we will see in the next video other agents than water as well. So today we will focus on water modeling, specifically talking about river water modeling, while water modeling and groundwater modeling, okay? So if this video sounds interesting to you, please subscribe, hit the notification bell, and if you like this video, give it a thumbs up. So let's start by rivers, because maybe it's the typical by excellence example of water modeling, okay? What is a river? So it's a long and permanent stream of water. Usually it goes from higher areas like mountains to lower areas to sea level, right? And we can divide the journey of the river into three parts: high course, medium course, or low course. Sometimes we can also see upper course instead of high course. So high, medium, and low courses. And on its way, water will erode and modify the earth surrounding, okay? So all the landforms related with rivers are gonna be are due to this movement of water, okay? But we have to divide into high course and medium low course, because the energy the water has is different and the result is gonna be different as well. In the higher course, the river has more energy just due to gravity. If you remember, agents are always controlled or related to two bigger energies or higher energies, which are solar energy and gravity. In this case, it's gravity because the river is going from up the mountain to down the mountain. As we are in the highest part of the river, gravity is gonna be stronger, so the energy of the river is gonna be higher. Which type of shapes we will find in here? We will find B valleys, so valleys in shape of letter B. You can perfectly imagine a valley with a river in the middle. This is the result. In the beginning, the earth was flat and a river was in the middle, and little by little the river will erode, meteorize, erode, and transport. Now you already know all weather. All the materials from the top to down in the river in another place. If the river has energy, material will be transported longer. If the river has less energy, materials will be transported less distance, okay? Apart from the big valleys, sometimes we can also have canyons. If the materials were softer, let's say, the erosion is not in a line making like this V shape, is more like straight. So in the end you will have a river in the middle and two straight walls around, and this is the canyon, okay? And of course we will also find waterfalls. And in the middle and low course, where energy is not high anymore, usually we will find structures, landforms related to sedimentation, not too much to erosion or transport. So all those eroded fragments from the higher course will be transported and sedimented in the medium and lower course, okay? So we can also find valleys, but these valleys in this case are gonna be wider, okay? And usually associated to river terraces on both sides. And the river terraces are the places where fragments that were transported will be sedimented, and the size of the terrace is going to depend on the amount of water. Okay, apart from valleys and river terraces, we also have a very interesting shape when the river makes a curve. Okay, this curve is not called curve, it's called meander, and you have the picture of a meander in here, so they are really typical as well. And finally, in the river mouth, when the river ends and get in contact with the sea, usually if the river was still transporting some materials, they will end sedimented in there in the mouth. Depending on the conditions of salinity, the flows, etc. We have usually two shapes for sedimenting: estuaries or deltas. The estuaries they are like smaller mountains dispersed on the mouth, by the mouth, and the deltas, they always have like a triangular shape. That's why it's called delta. And in here you have a picture with all the names I just said and their descriptions if you want to, or you need to see them again or write them down. Okay, so if you need, you can pause the video. I'm gonna put the picture in bigger now so you can see all the letters briefly. You can pause the video and then we can continue. The next example is wild waters. Wild waters or torrents is a special type of river that is not permanent. It's temporary and it's seasonal. It will appear in the season of rain or when snow is melting. But if there is no rain or no snow, the river will get dry and it won't be there anymore until the next season. That's why we call them torrents or wild waters. And usually they happen in a very short period of time, when it maybe in desert areas or in the snow, in the mountains, and those processes of rain or snow melting are really quick. So all the water is gonna be accumulated in this area in a short period of time. So it will be a lot of water with a lot of energy, and that's why they receive the name of wild waters or torrents. And they have some specific structures. You can see at least three. I'm looking at the screen. Yeah, 3-4 of these structures in this picture. Okay. So in the top of the mountain we have the reception basin. Then we have like the neck, which is the drainage channel, and on the base of the mountain you have the ejection cone. So the thing is, from all the little water streams will merge in this big reception basin, will go down straight in this kind of neck or drainage channel around the mountain slope, over the mountain slope, and on the base, when the mountain slope doesn't exist anymore, the water will expand, creating this ejection cone. Okay, and wild waters create different types of landform as well. It depends on the stone, the base, the rock is gonna be different. Okay, so if the base was a plutonic rock like granite, they create this type of landforms. And the picture specifically, this one is called groups. In Spanish is la piedra. Okay, so it is like a big rock surface with those cracks or grooves. That's why it is called like this. The English name is more descriptive than the Spanish name actually. And if the grooves, instead of happening in a flat surface, happen in the slope of the mountains, they look like these fingers. They are called badlands in Spanish, cárcavas. Okay, the vocabulary is really different. That's why I'm telling them to you in both languages. And finally, depending on the material, or if they were if was water. By the way, in the second case of the badlands, it's not granite, but usually it's in clay terrains or rocks. And the last case is they are called chimneys because they have like this vertical shape, like a tower or a chimney. And this is related with the next type of landforming, which is karstic, and it will usually happen in limestone. In the way of the water, they will erode the materials, but some materials sometimes are going to be stronger than others, so they won't erode all the same way. So in some cases, those towers or chimneys remain there because that part of the material was harder or stronger than the other one. So the other one was eroded and transported, but this one no. And we find these chimney shaped landforms. And finally, talking about groundwater, we will have two types. Just the normal groundwater that will form aquifers in any type of material, and we will talk specifically about what happens when this material is limestone in a few slides, okay? So groundwater landform happens when water infiltrates inside. It can come from the sea or from the rain from the continent, and it gets inside the earth. And inside the earth we will find 4 different structures, okay? You can see in this picture in here the light brown, can we call this light brown? The one in the top after the mountain is called the infiltration area. Okay, it's the part where water will flow down the earth from the earth's surface or sea. Okay, then the medium brown layer is the water area where water is confined in this aquifer. Okay, and finally the bottom, which is the darkest brown in here, is gonna be the waterproof base. It's a waterproof material that won't allow the water to keep going infiltrating down. So all the water is accumulated like in a bag in this water area. And from there we can create some wells, which is the right vertical stream we can see here. And we have 2 types of wells. Confined wells, which are the typical one. You have to make the hole and put a system with pipes and a motor to make the water rise. That won't happen naturally. But sometimes, if we are lucky, we can find a point in the earth where the aquifer is more or less at the same level. So just by creating this hole, the water will exit naturally, will rise naturally. These wells are called artesian wells. Okay, and similar to the artesian wells are spring waters. Spring waters are like lakes, kind of lakes, but from the bottom you can see some bubbles going up, or some kind of fountains, natural fountains in mountains. In this case, those springs water are water that is coming from the aquifer naturally, like in an artesian well, but without building the well. And what happens when this aquifer is located in limestone material? Limestone, if you remember in Spanish, is caliza. In the case of, it's a sedimentary rock. In the case of limestone, it happens a chemical reaction. Limestone is chemically calcium carbonate, and when it gets in contact with carbon dioxide, the water will mix with the carbon dioxide and will form carbonic acid. And this carbonic acid is the one that will react with the calcium carbonate, forming this calcium bicarbonate. Okay, the thing is that in the end, the water mixed with this acid will dissolve calcium carbonates, creating very specific and fantastic shapes in underneath, sometimes also outside, okay? So if they are outside, we call them exokarstic forms. Karsts, by the way, well, my class from this video knows why, but karst is an Slovenian word, and in Slovenia there is a region which is the karst region with a lot of caves, and Germans and other scientists, geologists were there to research about caves, and that's why it is called karstic modeling, because of this region, the karst region is Slovenia. And finally, so about the exokarstic forms, we have the pencils, which are these towers you can see in the picture, and sinkholes, when the water was on top, maybe in a lake, and it was slowly eroding the surface, and finally it contacted with an inner cave. This hole, we call this sinkhole, or more usually the Slovenian name polie, because the J is E in Slovenian, so polie. And in the case of the endokarstic forms, by the way, in Spanish we call them polie, we don't translate the name. In the case of endokarstic form, we have the typical caves with stalactites, stalagmites if they come from the ground, stalactite if it comes from the roof, and when a stalactite with a stalagmite gets together, we call this a column. If it instead of something like kind of round is a kind of inner river, we call them gallery instead of cave. And that's it for today. If you still have any doubts, you can leave them in the comments, and of course, see you soon.